Hi, my name is Paul and I'm thrilled to announce that we're launching a DGLux training channel. On this channel, we'll be posting focused lessons that will dive into a specific feature of DGLux. However, we're not going to be limited to just DGLux features. We'll also be inviting UI UX designers and even project managers to share their experiences and methods and tips and tricks to help develop a DGLux application. Basically, we'll be covering various backends whenever they relate to the topic at hand. This will include DSA, Niagara, Eclipse. We'll be using your feedback to put together a list of topics to cover. Like I said, we'll be covering one topic per lesson and dive into it in details using screencasts so you can follow along. I'm definitely looking forward to seeing you on this channel, and let's take it away. Hey, so first topic for our first lesson is repeaters. So what's a repeater? A repeater is a core feature of DGLux, a core component. The premise of it is very simple. It takes something you already have and it repeats it for a data set that you also have. What does that mean? If you build a small graphic, let's say a button, and you want to create a button for each of the devices that you have out there in the field. The devices come into you via a query, so you have a table, a data set that lists your devices. Repeater is that engine that will take your button and will repeat it for each row in your table. That's the basic premise of the repeater, but what it can do is very, very powerful. There are three types of repeaters. There's a visual repeater, there's a Dataflow repeater, and there's SVG repeater. First, we'll take a look at the visual repeater. All right, let's go ahead and dive right into the visual repeater here. So I'm starting from scratch. See, I have a clear playing field here. I'm gonna close all the pages. And here's what I'm trying to do under my data node. I have HVC subnode, which contains 10 devices. In this case, these are VV boxes. And I'm trying to create a navigational element which will list all of them and allow me to click on them and then give me an output of the selected VV so I can do something with it later. So on my page, I'm going to go ahead and set up two panels. I'm going to make the whole page horizontal layout, and I'm going to add one group that will act as my navigational group. Give it a fixed width. It's going to stay here on the left. I'm going to give it a light background, and I'm going to create another group that's going to take up the rest of the space. This group will act as a content holder. So left, I'm going to select something on the left and something will happen on the right. That part will not cover in this lesson. It'll come in handy later. For now, I'm going to make sure that our left-hand navigation does not resize when the content part grows or shrinks. So I'm going to give it 0 on the flex size. So it's going to stay 200 pixels no matter what. Now also I'm going to give it a little bit of a gap between it and the content, and I'm going to color the content with another color so we can clearly distinguish it. Maybe like this for now. Okay, so we'll call this nav for navigation, and we'll call the main group content. There we go. Last thing now, preparations. I want to make sure that my navigation is vertically laid out because when my VV navigational items are rendered, I want them to be all stacked vertically. So for my navigation container, I'm going to change the layout to vertical and give it a little bit of a gap again between the line items. Okay, so next thing we'll take a look at the what repeater needs to work. So here's the repeater section. You can find that on any group. So it takes two items: symbol name, we don't have one yet, and the data set, we don't have one yet either. So let's work on the symbol. Right. So I'm gonna go ahead and add a group right into my nav. And I'm going to set it 100% wide, so it's going to take the whole width of my navigation container, give it a fixed height, and that's going to be my future symbol, basically future element that I would want to repeat for each of my AVs. I'm going to make it a horizontal layout, and I'm going to give it some spacing on the left and the right for aesthetics. I'm going to add a text box into it. Blow it up 100% by 100%, so it just expands to my group size. And I'm going to go ahead and make this a symbol. So I'm going to right click it, convert to a symbol, and I'm going to call it navigational item, nav item. There we go. So now if we switch to symbols, we now have a symbol on our page. The symbol doesn't do anything yet, and if you try to repeat it, it'll just say text on all instances of it. So we need to give it ability to take in a value as the label. So I'm going to double click or right click and edit symbol to get into the editing of the symbol. And I'm going to add a symbol property to it. So I'm going to go to modify, edit properties. It's going to be a string property. I'm going to call it a label. I'm going to give it a default value of device, and I'm going to bind it to the text property of our text box. There we go. So now it just says device. So whenever I use this symbol, if nothing is being passed into label, so if null basically is being passed into the label, it will show the word device. Otherwise, it will show whatever is being passed into it. Now, I also wanted to be interactive. Specifically, I wanted to respond to being selected. So there's a property called selected. It's hiding under this little expansion box, right? And this property is what gets affected by external factors. So, for example, the group that's a parent of this group, if it has selection enabled, the way it works is by controlling this selected property. So I'm going to use this property to drive some of the color changes in my symbol to respond to selection. So you see selection selected as false here. I can manually set it to true, or it gets set to true by its parent group. So I'm going to map the selected property to the background of the whole symbol. So I'm going to hold Control on my keyboard and drop the binding. This gives me a binding dialog. I'm going to do Boolean mapping, and I'm going to say when it's true, I want the background to be dark gray, and when it's false, I want it to be white. And I'm going to go to my text and do the same, but reversed for my text color, font color. So I'm going to again drop it with a control. Gives me a dialog. So on selected true, I want the text to be white, and on the selected false, I want text to be dark gray. So there we go. Now it's set up. Now if I manually toggle selected, notice that my symbol gets inverted. That's what I'm looking for. And last touch, I'm going to give it a hand cursor so that when you mouse over, it's clearly visible that it's clickable. And I'm going to accept my changes. Okay, so I have a symbol that's set up the way I want. Now I need to use it somehow. So I no longer need an actual instance of it existing physically under my navigation container. So I'm going to delete it from here. And I'm going to go to my navigation container, scroll down to the repeater section, and now I can populate my symbol name into here. So I'm going to switch to symbols, just drag my symbol into the symbol property. All right, so that part is done. Now we need data. All right, so we're going to jump into the data flow, and we're going to start working on getting our data set. Now in this case, I just need to get all the children of the HVC node. So I'm going to use list node block for that. And for the path, I'm going to use the path of the HVC node. Now, if I simply dragged this into here, it would create a binding instead of just populating a path. But there's a shortcut. You can drop a node in the search box, copy it from here. I do Control X, so I cut it from here and paste it into the property where you're trying to populate a path. Right? So that gives us children, but they're not exactly in the order that I want. So I want to sort them. So I'm going to go ahead and use the sort block. Search for sort. There it is. I'm going to route the children of the list node block into the input of the sort block. Right? And I'm just going to open the output of the sort block to see how it responds to the sorting options. So first of all, I'm going to tell it what column I'm trying to sort by. That's going to be a name. And sort will be descending. Now, the problem is that when I try to sort it as a number, you can't really do that because you have alpha characters in here. So if I try to sort it as alpha, it doesn't really do that well either because numerically no longer makes sense. So for that, there's an option called mixed, and that does exactly what we're looking for. So it distinguishes numeric portion of the name and sorts on that, giving us the proper order. Okay, so now we're good. Now we can go ahead and take this input and bind it to the data portion of the repeater. So you notice that it immediately forced it to render 10 instances of our navigation symbol, but they all say device. Well, they do that because we're not passing any data into the label property yet. Notice that this render item appeared under the group as soon as we supply data to the repeater. So this is basically a virtual symbol. This refers to all the symbols that get rendered under this container group. And it has a label property. However, if we just try to type into it, ABC, that gets passed equally to every instance. That's not what we're looking for. We need it to come from data table. So we're going to go ahead and open the data table. All right, switch back here. Now, all right, so maybe let's try doing this. We'll grab the first one and bind. Well, that's not quite what we need either. That basically populates all of them with the first element, with a 1-1 VV, not what we need. Well, to do this properly, you actually have to grab a column header and bind the whole column to this property. That will make sure that each instance of a symbol gets a value from a respective row of the column that you bind, right? So this is what we're looking for. So properly labeled VVs. Now, remember that we also set up our symbol to respond to selection. Let's see if it does. Well, we do get a hand cursor, but it doesn't do anything when we click on that. So let's explore that. So under the selection accordion right here, we have several options. Default is none, so clicking does not select anything. We're going to switch it to a single select. So when we do that, well, that all of a sudden makes it work. So what it does is when I click one of the instances, it sets the selected index in this property here, and everything under the group gets indexed from 0 to number of elements in the group. So in this case, 0 to 9. 0 being the topmost, since our alignment here is vertical flex start, and of course 9 being the last in this case. Right. -1 will make sure nothing is selected. So notice I can type in here as well as click, and it kind of has the same effect. Now, toggle select will, of course, let you toggle between selected and unselected. And then multi-select will allow you to have multiple indices in here. Now, you can change these programmatically, or again, rely on the user clicks to do this just the same. Okay, so now they respond to the click. They get rendered properly. There's one last item that we need. Somehow we need to get an output of the currently selected VV so we can later use it to drive the rest of the content. And that is done quite simply with selected row block. So we're going to search for selected. There, select rows, right? And notice we're on Dataflow off of the repeater, and we have to stay there for everything to work right off the bat. And then we're just going to drop the block, and it comes pre-bound. So if you do this in the Dataflow, in the repeater's Dataflow, there's nothing else you have to do. Simply drop this block. It automatically gets a binding from repeater's data table. It automatically gets a binding from repeater's selected index, which is this index here, and it gives you the row that corresponds to the selected item. So as I click, notice that it gives me a row of the element that I clicked on, and from here I can bind to into my content area, into other logic that's supposed to do something wherever I want to. Now, if you're setting up your logic elsewhere, not on directly on the repeater's data flow, it's fine as well. But in that case, after you drop the selected row, you would have to come in and manually bind your data source and your selected index to the block, right? And then it'll work as it's supposed to. And that's it. So now we have a repeater that renders all of our VVs. It responds to the click visually, and it gives us the currently selected VV. And just to illustrate the proper functionality, we're going to go ahead and add one more VV to see if our repeater responds right away. So I'm going to go ahead and duplicate this node. I'm going to name it VV1-11. I'm going to invoke, and look at that. We got another VV populated automatically. That's all there's to it. Well, that didn't look terribly difficult, so now it's time to take a look at the Dataflow Repeater and then maybe try to connect the two and see what we can do with both Visual and Dataflow Repeaters together. Okay, so we're picking up pretty much where we left off in the previous exercise, and we're gonna expand our functionality here. Now, what we have so far is a list of devices created by a visual repeater based on a data set that we have on our server over here. So that will be now 11 VVs. And we're going to expand this a bit. So what we're going to do is we're going to create a Dataflow repeater that, in addition to fetching each of the VVs, will also fetch some of VV parameters, live values basically. So that would allow us to add some live data directly to our navigational items, and then also have it available for further content. So let's go ahead and explore this. If we jump into our data flow, let's look again at the table that's driving our repeater. Right, it has a name path and some of the other node parameters. It has no information about any of the subnodes, basically, or subnode values, which is what we're looking for. So let's start by dragging out the values that we want. Let's say for each of those VVs, we want to display, or at least have available, data flow, supply air temperature, maybe a filter alarm, and the damper position. So those four metrics we want to have available for each of our VVs. Now, first, for it to be usable by a repeater, we need to make it a symbol. So I'm going to go ahead and select all, right click, and convert to symbol. I'm going to call it VAV, so VAV data. All right, so notice that under symbols, right here, it's now available. It has no properties yet, so it doesn't do anything that we need. So I'm going to go ahead and get into that. So right click, edit symbols. And first thing that I need is I need to parameterize the path. Right now, each of those 4 blocks basically has a hard-coded path to fetch the data from VV1-1. Instead, we need to be able to supply a path of the VV for which we're trying to get the data. So I'm going to right click and go to symbol properties. I'm going to go into create a property called path. Right, and I'm going to accept the changes. So now we're back here. Now you see that now our symbol has the path property. And I'm going to go ahead and populate it right away. Notice I'm populating this not while editing the symbol, because whatever you do while editing the symbol will get saved with the symbol. So instead, I'm already done with editing. I'm going to basically supply this path right now. I'm going to use the same trick we saw in the previous exercise. I'm going to drag the VV node to the search box here, which displays the path. I'm going to Control X, so cut it from here and just paste it over here. This just saves me from retyping it. And I'm going to get back into my symbol editing. Right, and if I look at my properties now, I'm seeing the path property with that VV's path in here. So now I'm going to use all these blocks and replace the hard-coded path here with the parameterized path that comes from here. Right now I'm going to make them a little bigger so they're easier to read. And I'm going to use a concat block to create these compound paths. So first part is always the VV path. The last part will be slash plus the actual point name. So I'm going to go ahead and copy this. And I'm going to do that for each one, linking the output back to the get value block. There you go. So now we have logic that will fetch these 4 parameters for whichever VV we supply the path for. We just need one more thing. We need our symbol to also output these values. So it looks like we need three numbers and 1 boolean to output them. So I'm going to like so. And lastly, I'm going to make these properties read-only because the symbol will be outputting these values. We will not be expecting any input on those values. So this will prevent anyone from being able to bind to them when they use my symbol. Okay, that's done. So here's the symbol. Now notice this original version of the symbol, it has all the properties, but none of them are pinned. That's because I'm still creating the symbol. But if I drag another instance from my symbols, it will have all those already pinned to the block. Okay, so now the symbol just requires a path and it will give me my 4 values out of it. I just need to repeat it for each of the VVs. So to do that, let's find the repeater in our list of logic blocks. And I'm going to use the original table, this table here, I already have it displayed there, as the driver for the repeater. So that's going to be my data. My symbol is going to be the symbol I've just created. There you go. So I'm going to update this these properties by clicking outside and clicking back in. Right? So now it updated the properties there and it's displaying the symbol properties. And just like we did for the visual repeater, to populate this path with appropriate path for appropriate row, I'm going to drag the whole column, grab by the header, and just drag the whole thing and bind it to my path. Now, if we take a look at the output, we see a path of each of the VVs and the values that correspond to that VV. Now, most of them are identical because they're actually identical, but you see some are different, like this one here, true instead of false. Okay, now where do those columns come from? So the output of the Dataflow Repeater is always a collection of symbol properties. Whatever symbol, Dataflow symbol, that you're repeating, the repeater output will have a table consisting of those properties as columns and each of the instances as rows, right? So we have VVs coming in, right? So for each row, for each VV, we're going to get one of each of those properties. So that's what drives this table. So we're only missing one thing. To be able to use this table to drive our navigation group here, we need a name. So we're missing a label because our symbol doesn't have a name or a label property. So our output table doesn't have it either. So what we're going to do is we're going to simply join our data table, which drives the repeater, right here, and our output table, which gives us our properties. And we're going to join them on the path because the original table has a column path and our repeater output also has a column path because our symbol has a property name path. So now we have a table that contains all the columns from the original table plus the 4 value columns that our repeater output adds to it. Right, so let's close everything and we're going to link it to our navigation here. And that's what's going to drive our navigation from now on. So now we can actually take advantage of it. Right, so let's go ahead and edit one of the navigational items. So here I'm going to right click and let's say edit instance 0. So we're going to edit with the first value as an example. Right, and let's add, well, first let's add a display that shows you our filter alarm. So I'm going to add a little circle here. It's not very circly, but I'll fix that in a second. Let's do 15 by 15. Okay, and let me set the vertical alignment to center so that everything is centered. And now I need to be able to pass that data into my item render. Now I can do that by adding properties, just like we did with label, but there's another way of doing this. If I want to, delete that, we didn't need that. So if I want to just have access to any column of the table that drives this, I can, in the top root group for the symbol that's being repeated, in its data flow, I can drop a block called, just search for table, called map to table. What that does, so as soon as you drop it, as long as it's on the symbol's parent group, it comes pre-linked. There's nothing else you need to do. It always gives you a row, the whole row of a table that corresponds to this instance of a symbol. Makes it a lot easier. You don't have to pre-create all these properties and pass them in. Although this does limit this symbol to be used inside repeater only, because this block will not function when the symbol is not being used in the repeater. Okay, so we have this row of data that corresponds to this particular item. We have a circle that we want to use to indicate filter alarm. So let's use the circle fill to do that. So I'm going to use this filter alarm column, just that specific cell, right? With a right click, bound to the fill of the circle, saying if it's true, meaning there's an alarm, that I want it to be red. And if it's false, so anything else will be no fill, right? And I don't want any outline as well. Okay, so we're done, and there we go. So as you notice, my VV1-1 has filter alarm, and that's why it shows the red box. So let's pick another VV and manually set its alarm to true and see if that works. Hey, it works. So there we go. We just successfully combined functionality of Visual Repeater and Dataflow Repeater to achieve a specific functionality. Hey, welcome back. So as you saw, the Dataflow Repeater was not so difficult after all. So now it's time to take a look at the third and final type of the repeater, the SVG repeater. Let's see what it takes to set one up. All right, now we'll be taking a look at the SVG repeater. So I've set up a little playground for us to make the example a bit more easier to understand. So here's what I have. So I have a group that's a fixed width and height, so it's 1000 by 600 to make things easier for us with white background. I also created a little data generator script. So what it does, it generates data per these parameters. So number of rows that I want, the X and Y get generated within these constraints. So are H and W. Right, so this is the result. So it generates the amount of rows that I tell it to with these coordinates, and I can keep regenerating the data. All the data is random, so every time it generates, all numbers change randomly. Okay, so that's going to be our data for the SVG repeater. So let's go ahead and get started. I'm going to add SVG repeater to my group here. You can find it under charts, and it's under charts because its original intent was to solve some of the more custom and complex charting needs. So it's right here. I'm going to go ahead and maximize it to be 100% by 100% to fill our group completely. Right? Now I'm ready to go. So if you look at the SVG repeater properties, it has the data field, which is where we're going to link our randomly generated data. It has a data type symbol, which we're not going to utilize right now, but this is basically the symbol that gets shown when you hover over each of the generated SVG items. You have the SVG item itself and SVG definitions. This is where you can define effects that you can use and apply to SVG items. We're not going to go into that today either. So we're just going to focus on the SVG item, and we're going to use the simplest one, which is the closed path, basically a polygon. First we'll start with the most basic version of that. So I'm just going to, again, you can Google SVG code path, right? And there are plenty of places you can find examples. This is one I found, right? So this is the most basic SVG code, right? So it generates a triangle. And rules are pretty simple. So these width and height define the size of your drawing board. And then having a code followed by two coordinates defines your path. Capital letters indicate absolute position. Lowercase letters indicate relative position. So in our case, we'll be using relative position for most of it. Right. So first thing I'm going to do is I'm going to set the width and height to match our playfield, which was 1000 by 600. There we go. All right, now we need to take care of our path. So again, if we look at the table, we have columns X, Y, H, and W, and we're going to be utilizing these. So the initial dot would be an absolute position, so we're going to keep M here, which indicates start of the path in an absolute position. And we're going to start replacing the hard-coded numbers with references to our columns. In this case, X and Y. So like I said, a column name in square brackets gets replaced by the value from that column. So next step, so I'm going to delete all the steps except the final Z, which Z just means close the path into a polygon. All right, so next step will be relative position, which is lowercase l, and I want to step h amount of pixels to the right and 0 amount of pixels up or down. So this is going to be, sorry, not h, w amount of pixels to the right and 0 pixels up or down, right? So that draws a line to the right of the initial dot, right? Another L, so another movement. This time I'm going to move 0 pixels left or right, and I'm going to move h pixels down, then another L. I'm going to move minus w pixels, so moving back to the left, and 0 pixels up or down. And finally, just keeping Z here, we'll draw the final clothesline from our last dot to the first one. That should yield us, basically, in this case, 200 rectangles of various positions and various sizes. So let's see if we've done everything right. All right, I'm going to mouse out, and we have. There you go. So now you notice that they don't take up our full stage, and that's because I've actually reversed width and height. So here our height is actually 600 and our width is 1000, and that should force them to take up the whole set. And there we go. And just to demonstrate, and by the way, you can add style clauses here and use the full SVG code as required. So just to demonstrate the quickness of rendering here, I'm going to go ahead and just refresh the script. Just look at how quickly all these render, and I'm going to keep increasing. Let's keep increasing the amount of items. Let's go to 500, and let's go to 1000. All right, let's go to 5000. Oops, yeah. There you go. So if you had tried to do this with a regular repeater, repeating a symbol of a rectangle, of course you'd be running into serious rendering delays getting to these amounts of items. So hopefully this makes SVG usage fairly clear. We're going to definitely dive into it in a lot more details, showing the actual applications and some of the solution it provides to real problems. But for now, this is it. Thank you. And this brings us to the end of this episode. Today, we've looked at 3 repeater types and what it takes to set them up. In further episodes, we'll be going into much more details about each of those repeater types and looking at the real-world situations and some of the solutions. Until then, please like and subscribe. My name is Paul Sinenko, and we look forward to seeing you on this channel. Now go build something.